right, we have been talking quite a bit about functions that have x squared in a class. Quadratic functions. And when you graph a quadratic function, you get a parabola. Quadricep. One class. All right, parabola. And the general form, of course, of a quadratic function, Genesis. All right, and if we have the general form, we could actually find the vertex of the quadratic with what formula, Audrey?
Negative 1/2 b over you plug that into the equation.
So f of that, okay? And that's one way to do it, right? If we found the vertex, right, we know that the vertex is either going to be at the bottom of the curve as the curve goes upward, or it's going to be at the top of the curve as the curve goes downward. If it's at the bottom of the curve, we would call it a what, anyone?
Minimum.
A minimum point, or a relative minimum. It's the bottom compared to all the other points in the parabola. And how would I know that this vertex, for instance, is going to be a relative minimum, Abby?
If the a is positive or negative.
Okay, so it would be a relative minimum if
The a is positive.
If A is positive, then the vertex is a minimum point. Of course, then if the A is negative, that means the parabola class is going to go,
Maximum.
well, the parabola is going to go down, so the vertex would have to be a maximum point, a relative maximum at the top of the curve. Also, the domain of all quadratic functions is what, Maddie? All real numbers. And then to find the range of the quadratic, it's either going to be, Kendall, how do we find the range of a quadratic function? Michael?
I don't know.
Anyone? It's going to be the vertex's f of x value up to infinity if it's a minimum point, right? If the parabola goes upward, or you'll end up having negative infinity up to that vertex f of x value. Right? It just depends on whether it's a max or min, whether the parabola goes up or down. So domain's all real numbers. It's going to be the f of x value up to infinity or negative infinity up to this value, depending on the direction of the parabola. So if I gave you something like this at your seats, f of x is equal to 4x squared positive 8x positive 11. We could find the vertex just in its natural state here. At your seats, use the vertex formula to find the vertex of the parabola. What do we have to do, class? Factor out the 4. But let's be honest, the only part we're really focused on is right here anyway, right? If I factored out the 4, what would be right here? A 2. I'm not even going to do the work. I'm going to do it all in my head. I would be factoring out, I get a 2. And then I'd have to take negative half of that. What's negative half of 2? Negative 1. Do we really have to show a whole bunch of work for that? I don't think so, right? And then we just need to find f of negative 1, and that value is going to go right here. And what do we get for f of negative 1, class? 7. So there's my vertex, negative 1, 7. What's the domain of the function, class? Because it's always all real numbers. And what's the range of this particular function going to be, class? 7 to infinity. We're getting a parabola. It's going to go upward. This is my minimum point. There we go. Finding the domain and range. Now, there is another form that we use besides the general form that actually makes it a lot easier to graph the quadratic. And this is called the standard parabolic form. What does the standard parabolic form look like? Back to Michael.
Positive negative a times the quantity of x minus negative positive h squared plus or minus k.
There we go. And we said that the positive negative right here, class, tells us when we graph whether or not our parabola is going to be flipped, right, up or down, inverted, or vertically reflected is the way the book puts it, flipped. Does it go up or does it flip down? The A here refers to stretch or compression, right? If it's a bigger number, 2, 3, 4, whatever, it's stretched. If it's a fraction, you know, a half, a third, 3/4, it'll be smaller. The negative positive H, your horizontal shift, and the positive negative K, vertical shift. We could say that the vertex then is going to be HK, right? Depending on how you shift it, that tells you where the vertex goes. So if I wanted to put this into that form at your seats, do so. Go and take that parabola out of the general form and put it into the quadratic form. Or into the parabolic form. Take it out of the general quadratic, put it in the standard parabolic form. Yes, ma'am. Okay. Remember that to put it into this form, we need to start by factoring just the first two terms with whatever the coefficient of x squared happens to be. So class, here we'd have to factor out the 4. But we'd only factor it out of the first two terms, and that would leave us with x squared plus 2x. Remember, not factoring out anything but the number itself. We're going to leave a little bit of a gap, and we'll leave the positive 11 at the end. Then we're going to complete the square, which requires 2 steps, class. Again? Good, we're going to half and square, and what goes in the gap? A plus 1. But we need to offset the plus 1 by also subtracting, except it's not really a 1, class. It's really a... It's really a 4, isn't it? So if it's really adding 4, then to offset adding 4, class, I'd have to subtract 4. And then we're going to take this perfect square trinomial, factor it into the binomial squared, x plus 1 squared, and then we can combine terms here to get positive 7. And there's my quadratic. Here we can tell that we've got to shift backward 1, upward 7. There's our vertex, by the way. And we've got to have an amplitude here, or a stretch of 4. So instead of over 1 up, 1 over 1 up, 3 over 1 up, 5, it's over 1 up 4, over 1 up 12, oh my, over 1 up 20. And of course, we're not actually going to get that far. We might not even make it to the 12. But very tall, skinny parabola as a result. What's our base form, the most basic parabola of all, Maddie? Yeah, f of x just equals x squared, and for this we said, class, the vertex will be at 0, 0. And then again, as we add numbers or subtract numbers, it shifts it up or down. If we put in parentheses something with the x, well, if it's subtracted, we shift forward. If it's added, we move shift backward. If we were to put a negative in front, it will flip it over, and of course, as we just referenced, you have a number in front, it's going to stretch it, or could potentially compress it. This is what we were practicing in the homework class tonight. Books open to page 209. Have those 5 parabolas out. I believe you probably did 3 parabolas on one grid and then 2 parabolas on the other. So I'm expecting probably 2 Cartesian planes, but 5 total parabolas for homework last night. And let's see how we did. Number 15 was your first parabola. And just a moment to set up my Cartesian plane. Again, the y-axis gets renamed the f of x axis since we're dealing with functions specifically. All right, for number 15, we see the x squared, right? There's your base form, but there's 2 changes on number 15. What are those 2 changes? Kendall?
You're going to flip it.
Flip it?
And then we're going to shift 3.
Which direction, up or down?
Up.
Up 3. So we're going to go up 3, and we're going to flip it. So instead of over 1, up 1, it's over 1, down 1. Over 1, down 3. Over 1, down 5. And so we should end up with a parabola for number 15 that looks something like that. How many had a parabola like this for number 15? Okay, questions, comments? What happened? What did we mess up? Did we forget to flip it? Did we forget to shift it 3? Did we flip the wrong direction? Shift the wrong direction? What's up?
I mixed up H and K.
So you went sideways 3. Okay. Sideways 3? Sideways 3. Okay, yeah. So I'm going to share it anyway. I was talking to Genesis, and the question is, man, how do you remember, right? Because of the 6 of you in here, half of you shifted correctly, the other half of you shifted the wrong direction. Like, okay, there's got to be a way to remember this. So this is what we came up with. All right? If you have a function of x, right, we've got some number. If there's like an x, plus 4, whatever squared, plus, 7, okay? Which one's horizontal, which one's vertical? Well, it's like this. Okay, if you wanted to change your height, you wouldn't eat more. You put on high heels, right? Okay, you put on high heels and it changes your height. It's something on the outside of you, right? Something on the outside can shift you up, or if you took them off, shift you down. This is on the outside of the x. So that shifts you up and down. But if you wanted to get fat, okay, then you would put stuff on the inside of you, right? Well, this is on the inside, and this changes horizontally, okay? Now, again, however it helps you, okay? I also was faced with, okay, well, but you always have to do opposite, right? Well, think of diets. You know how half the diets that are out there, they actually backfire and you end up gaining weight in the end instead of losing the weight you thought you were going to lose? Okay, so just think, okay, yeah, we're going to change my horizons, but it's always going to backfire, so I'm going to always do the opposite of whatever it says. However, you got to remember, it's weird, okay? It has nothing to do with math, but if it helps you remember, if it's inside, horizontal, and if it's outside, it can change your height, okay? So whatever works for you there. Number 17, moving on quickly. What's the only thing we're doing different on number 17? Genesis? We're not gonna shift it by rise to. You mean shift it up? You mean stretch it to, right? And so for this, we're just gonna stretch it to. So the vertex is still gonna be at 0, 0 like we're used to, but instead of over 1 up 1 class, we're gonna go over 1 up 2, and then over 1 up not 3, but 6. And that's as much room as I've got, so we'll stop there. And so when we connect the dots, we end up with just a little bit of a taller, skinnier parabola there. How many had that on number 17? All right, we were perfect on that one. Good. Let's see. Number 19 was the next one. And 2 changes on number 19. And the math is going to be fun on this one. Abby, what are our 2 changes?
You have to move it up 2 and then multiply the 1/3 that by the 3/4.
Good. Our stretch is actually compression in this case. It's going to shrink it just a little bit to 3/4 of what we normally do. So we're going to start with the shift up 2, and then it's over 1 up 3/4. Then it's going to be over 1 up 3 times 3/4. What's 3 times 3/4? 9/4, or 2 and 1/4. Now remember, we're at 3/4. So 1 more fourth puts us on the line, right? So 2 1/4, right? So 1 would be still right below the line, 2 would be right below the line, and then 2 1/4 is right on the line. So we're going to be right on those points at 2, 5, and negative 2, 5. And then 5 times 3/4 class would be 15/4. That's 3 and 3/4. So we're going to over 1 up 1, 2, 3, and 3/4. And those are probably the only points we use. It's not noticeably different shape, I don't think, from a standard base form. It's pretty obvious difference between this one and the yellow one, right? You can see it's way wider or smushed compared to the yellow one, but even the base problem, 3/4 isn't that far off, so looks a lot like our normal one. How many had that? You did all the right calculations with the 3/4? All right, any questions on how to do those calculations? Questions? All right. Let's see, let's go ahead and do a new graph grid here since it's starting to get cluttered. And let's look at 23 and 25, right? Yeah, 23 and 25 were the next two that you had. What's the equation there in 23? Read it for me if you would. Audrey?
F of x equals 2 times quantity x minus 2 squared minus 11.
All right. Did you say minus 11? Okay. So right off, the minus 11 catches my attention, class, because I'm going to have to shift the whole thing down 11 units. So, since I'm setting up a new graph grid anyway, I am going to set my x-axis just a little higher than I usually do, so I have room to go down 11. And hope that I don't get burned on the next graph on number 25. All right, so, and I might, I don't know yet, I'm just thinking ahead.
It's plus 10.
You're saying I'm getting burned. Okay, that's unfortunate, highly unfortunate, because this thing only has so much space. I mean, it's your graph paper, right? You can just make the axes really tall, but I don't have that, that ability on here. Well, this one at least will work out great. So not only are we going down 11, what's another change we're having to make, Abby?
On 23, we have to go this way too.
Forward 2. Okay, so to the right 2. So we're going to go forward 2 and then down 11. So my vertex is going to be right here at 2, negative 11. And then on top of that, there's a third change we're going to make here, Maddie. Right, we're going to stretch it out too. So over 1 up, over 1 up, 6. Let's see, I'm at negative 10 right now, so 6 would be negative 4. And then over 1 up, 10. And so there's 4 of them. And if I wanted to, I could go all the way up here to the 6. And that's as far as I'm going to go. And so we get a rather tall parabola there. And how many had tall, slightly skinny looking parabola that goes really far down? All right, and unfortunately now I have no room to do the next one. So we're going to do questions on this before I erase it, because I'm too lazy to draw a whole new everything. So we're going to erase this guy, and then I'm going to reset my x-axis. And we'll put it through right, see I need more room this way this time, don't I? So we're going to set it down here. And so this is a positive 3, 6, 9, 12. That's 0. Negative 3, negative 6, and of course negative 3, negative 6, 3, 6, 9. All right, good enough. All right, what changes are we making on number 25? Give me one of them, Genesis. Actually, there's 4 changes on number 25. What are we doing? I'm not stretching 10. I'm going to rise 10, right? Those are the heels on the outside. So I'm going to rise 10 here. Also, Michael,
You're going to move to the right step.
I'm going to shift forward 7 units. So I'm going to go up 10, but I'm also going to go forward 7. So I'm right here at 7, 10 for my vertex. Also, Kendall,
You're going to stretch 4.
I'm going to stretch it 4. So this is going to be really skinny because it's stretched so thin, right? It's like taking a piece of bubble gum. As you stretch it, it gets thinner, okay? Or a rubber band, you stretch it, it gets thinner. Not because you're squeezing it inward. It's just, that's what happens when you stretch something. But also, while we stretch it 4, we're also going to have to flip it, right? We're going to invert it or reflect it down. So over 1, down 4. Then over 1, down class 12. And that's as far as I'm going. Over 1, down 12. I'm at 7, so I'm going to have to go all the way down to negative 5 to get a total of 12. And we'll call that good. And it's going to be almost looks like, you know, like a pencil point if you zoomed in real tight. Very tall and skinny. How many had this? For number 25. Questions on those? Now, it's nice as you look at 23 and 25 and all of those, they're already in the standard parabolic form for you. Isn't that wonderful? But of course, that's not how things always go. So if you were to set up another Cartesian plane on your graph paper, f of x equals x squared minus 4x plus 1, you'd have to put it into the standard parabolic form and graph. And that's kind of the whole process now. So put this into the standard parabolic form and then graph it. Once you finish the first one, go on to the second one, the yellow one. If you have questions on the first one, though, be sure to ask. Where's the algebra? Oh, okay, half and square. You have to forgot to square. And then also, whatever you put inside, we got to compensate for on the outside. So a couple things there. I'd recommend taking the time to show that binomial square. Just, oh, I see, it's up there. I see what you did with it. Okay. I was looking down, you wrote it up. So you prefer to draw it going down? Yeah. Kendall has found that she's more comfortable drawing a parabola going down than going up, so she just flipped the paper over, and that first parabola, she drew it down. It's easier. More power to you. Sometimes I wish I could flip the chalkboard. I think that's what I need to invent, a flippable chalkboard.
I mean, you could try flipping that one.
No, I'd take the whole class period. Take it down, put it up upside down. Then we just have to invert it for the next problem again. Question? Okay. So what?
This is fun.
You could actually just be a flippable teacher, and you could like
stand on my head.
Yes.
Yeah.
Or stand from the ceiling.
That
Strong
really makes
foot.
teaching fun.
Yeah, unfortunately, my talents do not lie in such thing that you just have a boring teacher who walks on the floor.
You could try flippable chalk. Flip your chalk inside out, see if it's easier.
I don't think that would work. And there we go on the second. Any questions on what we're doing here? Looks like most of you are about done with both. Any questions on these? Are we good on the algebra? Are we good on translating the algebra into the graph? Anyone say, can we do one more before we take a quiz over this? All right, let's do one more. You can probably use the same graph grid. And let's do f of x equals 3x squared plus 18x plus 20. F of x equals 3x squared plus 18x plus 20. I'll actually leave the yellow one up for a little bit.
I don't think I can fit this one.
No?
No. That's what did.
Okay. I was about to say, I'm trying to do it in my head. I'm getting it to work for me, but...
I forgot to take 3 out of the 18.
Gotcha. All right. Questions on this one? How many got it? Questions then. Seeing a few people know. Questions, comments? Remember, don't forget to take it out on the back end. Now, if you're going to put a 9 in here, or rather a 27 in here, make sure we take it out on the back end, which is really good because otherwise a plus 20 is just annoying to try to graph. But factor, complete the square, half and squared. 3 is half, squared is 9, and then graph from there. Questions? All right, clear desk except for a clean sheet of paper, pencil, calculator, and everything else away. The time has come.
We need graph.
You do not need graph paper. The sheet of paper you have is for a cover sheet. You'll do all your work on my quiz copy.
You need more than one color pen.
You will not, no. So just a pencil, paper, and calculator as we take quiz 25. When you get your quiz, put your first and last name at the top of the paper, even though there's not a blank that says name. Put your name up there anyway. First and last name at the top of the paper. And today's date is 2/10/22. 2/10/22. Numbers 1 through 10, write the answer in that space below each question. So it's double space, there's a little space to write. Write your answers for 1 through 10 below each question. And then for numbers 11 and 12, we want you to go ahead and graph those. Remember, it's a graded graph, so make sure you mark the axes, the Cartesian plane, appropriately. Show your work off to the sides there on 11 and 12 as needed, and be as neat as you possibly can be. All right, you may begin. For number 3 and number 5, choose how you wish to solve. I'm not picking. It's whatever you feel more comfortable with. If you need to do work on your loose paper, I suppose that's okay. My goal would be to do it all directly on the quiz paper, but if you need to do work on loose paper as you're covering your answers, that's fine. you work on those graphs, make sure you keep your other answers covered. Just another minute or so to be finishing up. All right, if you would go and take out your textbooks, turn to page 208. Turn to page 208. And we can, now I will admit, these word problems are slightly contrived and less than perfect in a lot of ways, but we can even use these ideas of parabolas to discuss different types of word problem scenarios. So I want to look at a few of those as we wrap up the hour here today. Page 208, there's a sample word problem for you. And let's have Audrey, if you'll go ahead and read that for us.
The majority hair salon is open from 9 a.m. to 9 p.m. on weekdays. The number of customers the stylist receives follows the parabolic curve fx equals negative x squared plus 28x minus 184. Determine the time at which the most customers are expected. What is the maximum number of customers expected at that time?
All right, how many of you have seen on like Google or whatever when it's a business and talk about more busy, less busy, how busy it is during different hours? It's something I look at depending on, if it's a place I don't go very often. And you know that obviously most places in the beginning of the day when they first open, usually not super busy. And then as the day wears on, it gets busier. And then later in the evening, it tends to taper off. Now, is it perfectly parabolic? No. Is it going to be parabolic per this parabola? Highly unlikely. Okay, but we're just going to roll with it, okay, and say that roughly there's this parabolic curve that shows that as the day wears on, they get more and more customers, and then it begins to taper back off again. And they tell us that the quadratic that it follows is the quadratic f of x equals negative x squared plus 28x minus 184. So the question is, what is the peak time for customers? Well, to find the peak time, that would be the vertex time, correct? So we really just need to find the vertex. A couple ways we could do it. I might think we would factor out the negative. Complete the square. So if we half and square, the book does it this way. They take the 14 squared is 196. And but it's really a negative 196, isn't it? So we're going to add a positive 196 to offset. We'll end up getting the negative x negative 14 squared, and that combines for what, a plus 12? Well, the vertex of the parabola is at 14, 12. Remember that the function of x is describing as the time wears on from 9 a.m. to 9 p.m. or 2100 hours, as the book points out. As the time x wears on, the function of x value, the number of customers, increases and then decreases. Well, this is the peak time. Right here, the x value is the key time, 14 o'clock. Okay, practically speaking, that would be class 2 p.m. So apparently 2 p.m. is their peak time. I don't know if it's because it's after lunch. I don't know what the deal is, but 2 p.m. is the key time for hair salon to get customers. The f of x tells you how many customers they have at their peak time. And so at the peak time, how many customers are sitting there getting their hair fixed? 12. 12 customers at 2 p.m. And so we can use this parabola idea to solve that. Let's look at a couple more problems over on page 210 now. Go ahead and read problem 45 for us, if you would, Michael.
The profit of the day in hundreds of dollars for Riley's Auto Service can be graphed using the equation y equals negative x squared plus 8x plus 33. Determine the point where the profit reaches its maximum. What is the maximum profit?
All right, so I'm guessing this is kind of the same kind of thing where as the day wears on, they're making more and more money doing things, fixing things at the auto service place. Then as the day tapers off to the end of the day, fewer people coming in to get the car fixed. All right, so they use y instead of f of x. That's okay. We can roll with that. Negative x squared plus 8x plus 33. Really, to find peak profit, all we have to do is find the vertex. All right, so at your seats, find the vertex. All right, how many got the vertex? 449. 449. All right, presumably, again, the x is the input. Presumably, this is 4 hours into their day, which on an 8-hour day means halfway through their day. Presumably, 4 hours into the day, they're having their maximum service done, therefore maximum profit to the company. The f of x, or the y value, is the amount of profit, but it says it's the amount of profit in, first sentence, Class, the amount of profit in
dollars.
hundreds of dollars. So how much money are they raking in at the key point of the day? $4,900 is that maximum profit at the peak time of the day. Okay, that's what it seems to indicate there. Number 46, this is highly unrealistic, but we'll roll with it anyway. Number 46, read that for us if you would, Abby.
A rainbow's path follows the parabola y equals negative x squared plus 10x plus 5, where x represents feet above the ground. Find how far above the ground the rainbow is at its highest point. Include the point. All
right, change that to say where y represents feet above the ground. X is not going to represent feet above the ground, right? That would be y. Vertical is feet above the ground. So that's just a typo on their part. All right, at your seats, let's find the high point of the rainbow. And if you find the end of the rainbow, supposedly there's a pub, but I don't know. What is the vertex of our parabola? Class? 530. So remember, the y value is telling you the height. How tall is this particular rainbow? 30 feet, apparently, because it says y represents how many feet above the ground. So apparently 30 feet is how high into the sky this particular rainbow extends. Questions on that? All right, you're going to have a couple of these in your homework this evening. Homework is to do page 220. Page 220 to 221, numbers 35 to 42, so a little bit of a shorter assignment than usual. Pages 220 to 221, numbers 35 to 42. Also, we have a test coming up in lesson 118. Lesson 118, so that's still a week away. That's this coming Wednesday. Okay, so about a week away yet. But I want to let you know that is coming. That'll be over sections 4.6 to 4.9 tomorrow. We'll go over our final test topic. And then Monday, wrap that. Tuesday, review. Wednesday, test. Again, that'll be lesson 118. All right, have a wonderful rest of your day, and you are dismissed.